Okay, first step, we need to write all information given. So the mass of cue ball is 0.17 kilogram. Okay, and then mass of red ball is 0.16 kilogram. So the time for the cue ball to hit red ball is 2 seconds. I hit the red ball, it's 2 seconds. Alright. So, and then next steps, we need to do free body diagram, which is FBD. So this is cue ball, and then we have normal force, and then weight. So weight, we need to times gravity, which is 9.81. So mass of cue ball 0.17 times gravity 9.81. So this is W weight, and then the force given is 0.4 Newton. Okay, this one is force given. Okay, and then we need to do summation of force. So we need to do summation of force in x-axis. Then this one, summation of fx equal to mass times acceleration of x. So we assume right, going to right is positive. Okay, then the force which is have in x-axis is 1 only, so this one 0.4, so it's going right, then we consider it positive, so 0.4 Newton. And then mass of cue ball, so 0.17, and then acceleration of x that we want to find. So this one, so at x we calculate, we get 2.3529 meter per second square. So this is unit for acceleration. And then next steps, we need to do summation of force in y-axis. So we consider it going upward is positive, right? Okay, then mass times acceleration of y-axis, and then the force which is have in y-axis 2, normal force and weight. Okay, oh sorry, the normal going upward. Okay, so the normal going upward, so it positive, and then weight, so weight going to downward and then negative. So you calculate 0.17 times 9.81, we get 1.6677. So the mass is 0.17. So the acceleration of y equal to 0 because the ball going move to x-axis, so 0, and then this one. Okay, so we get n is 1.6677 Newton. Newton is unit for normal force. And then we use kinematic equation. So V equal to V initial plus acceleration times time. So V that we want to find, so V initial we consider it 0. Okay, so 0, and then plus acceleration, we get this one 2.3529 times 2 seconds times time by hits the red ball, so 2 seconds. And then we get the velocity 4.7058 meter per second. So meter per second is unit for the velocity. So the velocity of the cue ball to hit the red ball is 4.7058. This one. Thank you. Okay, for this second question, we want to find the final velocity, which is the final velocity of the cue ball and the final velocity of the red ball after the collision. Okay, for this question, we use the momentum equation, which is momentum initial equal to momentum final. Okay, first thing we must solve for the x-axis. Okay, final momentum of x-axis equal to momentum final of x-axis. Okay, for the momentum, P equal to mv, which is mass time velocity. Okay, mc vc initial of x-axis plus mr vr initial momentum equal to mc vc final momentum plus mr vr final momentum. Okay, this one for the initial momentum for the cue ball, which is mc vc plus the final momentum, the initial momentum of the red ball, which is mr vr equal to the final momentum of the vc cue ball, mc vc plus the final momentum of art ball, which is mr vr. Okay, so we know the mass of the cue ball is given, which is 0.17. Okay, divide times the velocity of cue ball, which is we have calculated in the first question number 1, which is 4.7058. Okay, for this plus, okay, mass for the red ball is given, but the initial velocity at the red ball is, we know the red ball at the initial velocity of the red ball is at rest, so we know the velocity initial of r is 0. So from that we know 0, so we can eliminate for the red ball of the initial momentum. So
So we plus 0 and equal. So mass for the cue ball is 0.17 times by velocity of cue ball at the final momentum we not know. So we resolve it with two axes, which is x axis and y axis. So VCF velocity of cue ball final, we resolve it for the x and y axis. So VCF cos 55 plus, okay, mass for the red ball is 0.16. Mass by the velocity of the red ball is, which is at this direction. Okay, we know this, we RF we not know. So we RF cos 30, because this angle is 30 and this direction is at the direction. So we calculate, we get for this, for the initial momentum, we get 0.8 equal to, okay, final momentum for the cue ball is, which is this part, we get 0.0975 VCF plus, for this part, for the final velocity of the red ball, which is, we calculate, we get 0.1386 VRF, velocity of the velocity final for the red ball. Okay, for here we get one equation. Okay, next, when we, after we get for the first question, we must do for the momentum of the y-axis, which is momentum for initial momentum of y-axis equal to momentum final of y-axis. Okay, the initial momentum of y-axis is, the formula is same like this one, for like at this equation, which is MC VC initial y-axis plus MR VR initial of y-axis equal to MC VC final momentum of y-axis plus MR VR final momentum y-axis. Okay, this one is for the initial momentum of the cue ball at the y-axis plus the initial momentum of the art ball at the y-axis equal to momentum of the cue ball final, this one is for the final this one of for the final momentum of cue ball plus the final momentum of the art ball. So we get okay, from here we know the velocity of cue ball is 0 and the velocity of art ball is 0 because the initial velocity of cue ball and art ball in y-axis is 0 because the velocity only at the x direction at axis. So we can eliminate for the momentum at the y-axis. So we have 0 equal to mass for the cue ball is 0.17 times by because this two direction which is y and x axis, so we resolve two direction, and for this direction is negative because it's point to the downward, so negative VCF sine 55 plus mass for the art ball is 0.16 times VRF is going to the upward and is positive, and sine 30. Okay, from here we calculate, we get 0 equal to negative 0.1393 VCF plus 0.08 VRF. Okay, we get for the two equation. Okay, for the first equation we have two unknown, and for the equation 2 also we have two unknown, so we use the simultaneous equation. Okay, for the final state we must do the simultaneous equation because we have two unknown. So for the first equation we get from the momentum equation, which is for the at axis, and equation 2 we get from the y-axis. So here we get two unknown, so we use the simultaneous equation. So from the equation 2 we let VCF, so VCF equal to 0.08 VRF over 0.1393. Okay, from here we use the first equation and we replace the VCF to get the value of VRF. So 0.8 equal 0.0975. VCF we replace with this one, so VCF we times by 0.08 VRF over 0.1393. Okay, plus 0.1386 VRF. So we calculate for the bracket first, and we get 0.8 equal to 0.056 VRF plus 0.1386 VRF. So we plus for the VRF and calculate, we get 0.8 equal to 0.1946 VRF. So we can get the VRF. So VRF equal to 0.8, we divide by 0.1946, and we get the VRF 4.111 meter per second squared. So we get for the VRF, which is the final velocity for the red ball. So we, for next step, we find for the VCF. So VCF equal to, we take for this one, VCF is 0.08. VRF, we replace for the this one that we have earlier, 4.111 over 0.1390. So we calculate for this one, we get 2.3619. So we get for the VCF, which is the final velocity for the cue ball. Okay, that's all.